Ever wonder what lets a rocket nozzle survive insane temperatures? Or what gives a drill bit the power to slice right through solid steel? Well, the answer is often a hidden hero, a real heavyweight champion of the metals world that's working behind the scenes. Today, we're diving into the epic journey of tungsten. So, what's the big deal with tungsten? What makes it so special? Well, to really get it, you've got to start with its superpowers. This is a metal that is literally defined by extremes, and its most famous quality is its absolutely insane resistance to heat. Get a load of this number, 3,422 degrees Celsius. That is tungsten's melting point. It's the highest of any metal on the entire planet. This extreme property makes it pretty much indestructible by heat.
Now, to put that into perspective for you, think about iron, the backbone of all of modern industry. It melts at just over 1,500 degrees. At that same temperature, tungsten, well, it's just getting warmed up. It is in a completely different league. No contest.
So you've got the highest melting point, you've got incredible strength even when it's glowing white hot, and it's extremely dense and hard. This unique cocktail of properties is exactly why tungsten, which by the way is also known as wolfram, is the absolute go-to material for the toughest jobs you can possibly imagine.
So where on earth does this stuff even come from? Its journey doesn't start in some high-tech lab. Nope, it begins deep inside our planet over a process that takes millions and millions of years.
You see, you don't just find chunks of pure tungsten lying around. It has to be born from some pretty intense geological pressure. We're talking about super hot, mineral-rich fluids from magma that get forced into rock, then cool down and leave behind these special mineral ores.
And because these geological conditions are just so rare, the good stuff, the viable deposits, are really only found in a few places around the world. And as you can see, China absolutely dominates global production. This concentration makes tungsten a critically important and highly strategic material. Basically, whoever controls the supply has some serious leverage over the world's high-tech industries.
Okay, so how in the world do you turn a piece of rock into a super metal that you can't even melt down? Well, the process is every bit as unique as the material itself. It's really fascinating.
Because of that ridiculously high melting point, you can't just melt tungsten and pour it into a mold like you would with steel. It just won't work. The solution is this really clever process called powder metallurgy. First, the ore is crushed, then it goes through a bunch of chemical processes to get it super pure, and eventually it's turned into a fine metal powder. That powder is then pressed into a shape and sintered, which means it's heated so intensely that the little particles fuse themselves together without ever turning into a liquid. How cool is that? And all of that incredible effort creates this true hero material, this hidden workhorse that is humming away behind the scenes in pretty much every single piece of advanced tech that we rely on today. One of its most important forms is something called tungsten carbide. By mixing tungsten with carbon, you create this material that is so unbelievably hard, it's actually more like a ceramic than a metal, that it can just slice through hardened steel like it's nothing. This is the stuff that makes those high-performance drill bits and industrial cutting tools possible, a total game changer.
Now, think about the extreme environments of aerospace and defense. Its properties are just invaluable there. That crazy heat resistance, perfect for rocket nozzles that have to channel unbelievable amounts of energy. And its incredible density, that makes it ideal for everything from radiation shielding to tiny, heavy counterweights in high-performance aircraft. You know, a lot of us probably first met tungsten as that tiny little filament inside an old incandescent light bulb, the part that would glow white hot without breaking. And while that tech has mostly faded away, tungsten is actually more critical now than ever. It's playing key roles in X-ray tubes, in microchips, and even in the designs for future fusion energy reactors. And its impact doesn't stop there. In the world of medicine, tungsten's density is used to protect patients and doctors from harmful radiation. It helps focus the beams in radiation therapy and allows for those crystal-clear diagnostic images that we all depend on.
But the story doesn't just end when a tungsten part wears out. In fact, its journey is circular. It continues through this incredibly robust cycle of reuse.
Look, creating tungsten from raw ore is a super energy-intensive process. There's no way around it. But here's the kicker. It is highly recyclable. And producing it from recycled materials, that takes way less energy, which makes a massive difference for the environment.
And we're not talking about some small niche recycling program here. Processing worn-out tools and leftover manufacturing scrap is a major part of the global supply chain. It's a critical piece of the puzzle that helps reduce the environmental impact and keeps the supply of this vital metal stable.
So yeah, the whole story of tungsten really is a story of extremes. From its fiery birth deep in the earth to its one-of-a-kind properties and its life inside our most advanced technologies, it consistently just operates where almost nothing else can.
Tungsten has always been our answer to the toughest material challenges we've faced. So the real question isn't about what it's already done, but what it's going to do next. As we keep pushing the boundaries of science and technology, into fusion energy, deep space exploration and beyond, the challenges are only going to get more extreme. And you can bet that our reliance on this hidden, heavyweight champion of the metals is only going to grow.